Hi, welcome to another session of Circuits and Networks. In today's class, we are going to deal with the problems involved with supermesh analysis. So here we are going to apply supermesh for the problems involved with independent sources as well as dependent sources. So you can see an example of independent sources applied to passive elements, as well as you have independent and dependent sources whose dependency, for example, you have voltage dependent current source whose dependency is across 3 ohms. So how to solve these kind of problems? Using supermesh technique and then cross checking the result with any other approach. That is what we have, node analysis or supernode analysis or any other method which we can employ in order to cross check the result that we have to employ using the known techniques. So we'll start with the basic analysis of supermesh. So what does a supermesh and supernode circuit is all about? So we have dealt with the previous classes that whenever a voltage source is shared between two nodes or junctions, it forms a supernode. For example, here you have V1 and V2 identified nodes where 6 volts is connected between V1 and V2. So this forms a supernode. Why it forms a supernode? There is no other parameter connected between V1 and V2 other than 6 volts. So the higher potential of 6 volts is at V1, the lower potential is located at V2. So the value of V1 minus V2 will be equal to 6 volts. So this is about the supernode. What does a supermesh indicates? Whenever a current source is shared between two loops. Here you can see we have three loops, loop 1, loop 2, loop 3, carried by the loop currents I1, I2, I3. So the two loops are having a common current source as 2 amperes. So it forms a supermesh. So fortunately for this problem, we can solve using supernode as well as supermesh. So let us go with the solution. We need to find out the value of current in 4 ohms. Okay, for the circuit shown below, which is in given as figure 1. So we can do this problem using supernode analysis as well as supermesh analysis. In my last class, we have solved some numericals based on supernode techniques. So we'll start with supernode technique. So take the circuit as it is, identify two nodes, and clearly it is observed that V1 minus V2 is equal to 6 volts. So treating this equation as 1 and then applying KCL to node V1 as well as node V2 together. So what we have to do? We have to apply KCL at node 1 as well as node 2 and combine both them because it's a supernode problem. So here you can see to node 1, 5 amperes is coming as input, so it becomes incoming, so that's why it is taken as minus 5. Then you have V1 by 2, this is another branch current which is going away from V1 by assuming we want to get higher potential. So we are done with this node 1. Just conclude with node 2 in the same equation. So in node 2 you have 2 amperes which is incoming. So that is why here also it is minus 2 plus V2 by 4. So you can see V2 is parallel to 4 ohms also. So that's why it is V2 by 4, another branch current. So this is how the equation is framed. When you are considering individual nodes, that node you have to assume to get higher potential. Overall, V1 minus V2 is equal to 6 volts. Now this becomes a supernode and the two equations of supernode will be formed like this. You have V1 by 2, so V1 by 2, you have V2 by 4, V2 by 4, minus 5, minus 2 becomes minus 7, it goes on the right hand side becomes plus 7. By taking proper LCM, that is 4, I will be getting the equation as 2V1 plus V2 is equal to 28. So these two equations you need to solve in order to obtain V1 which is equal to 11.33 volts and V2 which is 5.33 volts. What we need to find out? We need to find out the value of branch current 4 ohms. So I4 is equal to, according to Ohm's law, V is equal to IR. So I becomes V by R. V is nothing but V2 applied parallel to 4. So V2 by 4, which is equal to 5.33 divided by 4, give you the value as 1.33 amperes. So this is an easy approach to solve this problem. Although you know mesh analysis or supermesh analysis, node analysis will also give you a better solutions. So you have to find the suitable solution in order to get the proper answer on time. So the same circuit, if at all we need to find out the current in 4 ohms using mesh analysis. How do we do that? So I told you 2 amperes, it is shared by two loops. So I1 I'm taking loop 1 and I2 I'm taking loop 2 and I3 I'm taking loop 3. I1 is clearly observed to be 5 amperes because the value it is given as 5 amperes. The loop current direction and the source current directions are one and the same. Then taking the supermesh equation. So first I3 minus I2 will be equivalent to 2 amperes. Now this becomes a supermesh equation. Why it is I3 minus I2? Because the alignment of loop current I3 and the given source current direction 2 amperes are one and the same, whereas I2 direction is opposite to the 2 amperes direction. That's why I have taken the equation as I3 minus I2 is equal to 2 amperes. I hope you understood why we have taken minus over here. So treating this is the equation 2, then applying KVL to loop 2 and loop 3 together. So the rest of the parameters you have to consider. So we are starting with 2. 2 times I2 minus I1. So this is another voltage drop over here. Then plus 6 over here. Then we are crossing the 2 amperes over here. And we have 4 I3 equal to 0. So according to the Kirchhoff's voltage law, algebraic sum of the voltages in a particular circuit is equal to 0. That is what we have applied. And we got the equation which is equal to 2I2 plus 4I3 is equal to 4. This we are treating as equation 3. And just solving equation 1, 2 and 3, we get I2 is equal to minus 0.666 amperes and I3 which is equal to 1.33 amperes. Now I3 is the same value of the current which is flowing in 4 ohms. So I4 is equal to 1.33 amperes. This is the same solution what we have obtained using supernode technique. So that is how you have to cross-examine the result. I hope you understood this method. Let's go with another example. Determine the value of current in 4 ohms. Here also it is in 4 ohms per circuit shown in figure 2. So the circuit is changed. Though the current we need to find out across 4 ohms, that is the same thing which we have seen in the previous problem, but here the circuit is given as different. There you had 3 loops which are placed side by side, but here you have a T section. So interpreted you can see a T section covered by the rest of the parameters. So how do you solve this? So let us start with supernode analysis. So I'm identifying node 1 center as V1, another node voltage V2 over here as V2 and V3 over here. Just for a change, I have changed the positions of the node voltages, though my approach will be the same under node analysis, but I have identified the node positions in different. You see how the technique is involved. Okay, so we have identified nodes V1, V2, V3. Now it is clearly shown that node V1 and V2 are sharing common voltage source, then it becomes a super node. So V1 minus V2 is equal to 2. This is the first step under supernode analysis. Then collect the parameters which are connected to node 1 as well as node 2. To node 1, you have 6 volts in series with 2, which is connected to node V3. Then you have 3 amperes which is coming towards node V1. Though you have 5 ohms, this 5 ohms carries a series current 3 amperes. So overall from this point to this point, the current will always be the same in series. So 3 amperes is coming towards node V1. And after this node, we have to jump to the next node, that is V2. V2 is shared by 2 amperes in series with 12 ohms. So 2 amperes is incoming, and V2 by 4, it is another branch current which is attached to this particular node. So overall we have to take these two nodes at a one frame of equation. So applying KCL to node V1 and V2 respectively, we get, see, minus 3 it is coming towards node V1, so minus 3 plus V1 minus V3 plus 6. Why plus 6? Because a higher potential 6 volts is connected towards 3, that's why it is plus 6 by 2. 2 is the total resistance connected between node 1 to node 3. So this becomes the common resistance between these two node points. So this is the resistance we are taking in the denominator. Then after this, we have to shift to the immediate node, that is V2. So under V2, 2 amperes is incoming. That's why it is minus 2 plus V2 by 4 is equal to 0. Okay. Now this you can see I have V1 by 2 minus V3 by 2. Then you have V2 by 4. So whenever I have V1 by 2, 1 by 2 it is 0.5. So 0.5 V1. Okay. Then V2 by 4 becomes 0.25 V2. Is this okay? and you have minus V3 by 2, it becomes minus 0.5 V3. So these three values of V1, V2, V3 are found in equations accordingly. Now you see we have minus 3 here and we have minus 2 here. 6 divided by 2 will give you the value as plus 3. So the plus 3 and minus 3 goes off. So this minus 2 shifts to the other side of the equation and becomes positive 2. So this is how you can solve a basic equation in decimal form without taking LCM. If at all you take LCM also, you will get the appropriate multiples of this values. Anyhow, I hope you understood how you got this framed equation as equation 2. Now once we are done with supernodes, that is V1 minus V2 equal to 2 and the other parameters which are connected to V1 and V2, let us go with the node 3. So applying KCL at node 3. So here I have branches which is connected to node 3, which is nothing but V3 by 2. So here you can see V3 by 2. Then you have V3 minus V1 minus 6 by 2. So V3 minus V1 minus 6 by 2. And 2 amperes it is outgoing, that is why it is positive. Okay. Now the thing what we have done under equation 2, the same thing we are going to apply over here. See, you have minus V1 by 2. So minus V1 by 2 becomes minus 0.5 V1. You have V3 by 2, V3 by 2. So 2 times of V3 by 2 becomes V3. Is this clear? Okay. And you have minus 6 by 2. Minus 6 by 2 is minus 3. Minus 3 plus 2, it becomes minus 1. So minus 1 goes on this side, so it becomes positive 1. Now simply solve 1, 2, 3 equations. We will get V1 equal to 6 volts, V2 equal to 4 volts, and V3 equal to 4 volts. We need to find out the value of current in 4 ohms, which becomes V2 by 4, which is nothing but 4 by 4, which is nothing but 1 ampere. I hope you understood how I have obtained the value of current 1 ampere in 4 ohms using supernode analysis. Let us go with another approach, that is supermesh analysis, so that you can get a grip over the topic as well as the solutions. So that's why I'm taking the same circuit under mesh analysis. And why it becomes super mesh analysis? Because 3 amperes is shared between these two loops. So identify loop 1, loop 2, loop 3. Then you can see I2 minus I1. I2 minus I1 is equal to 3 amperes. That is easily obtained by cross-examining these two loops. Then also I3. I3 is equivalent to 2 amperes. Is this clear? Now collect the rest of the parameters which are attached to the super mesh. That is 2, 2, 6, 2, 4. So you can see applying KVL to loop 1, loop 2 together. So starting with 2, it becomes 2I1 plus 2, I1 minus I3. On the path I am getting positive 6, so positive 6 plus just I shifted to the next loop, that is second loop. You have 2 plus 4, I2 equal to 0. So you can see you have 2I1 plus 2I1, 2I1 plus 2I becomes 4I1. Okay. Then you have 4I2, so the 4I2. Then 6 plus 2 it becomes 8. Whereas I3 is 2 amperes. So I3 is 2 amperes. So 2 times multiplied with minus 2, it becomes minus 4. So 8 minus 4, it becomes 4. So 4 taken on the opposite side becomes minus 4. Is this clear how this equation is framed? Right. Now solving equation 1 and equation 3, I'm going to get the value of I1, which is equal to minus 2 amperes, and I2 is equal to 1 ampere. So I2, which is the current flowing in 4 ohms, it is the same current what we have obtained using supernode analysis. That is a way to cross check the result. I hope with these two numericals you have got an idea how to solve a problem, and after getting the solution you have to observe that the magnitude and the direction of the current what it is given in the problem, it is always needed to be obtained as the same positive result. Now this example, that is the example which is shown in figure 3, we have already solved using supernode technique. This problem already we have solved using supernode technique. For that you can go with my previous video, that is the last video. You can see the same problem we have solved using supernode technique. So here we are trying to solve the problem using supermesh analysis. Why supermesh analysis? because you can see 8 amperes is shared between these two loops. So I'm identifying the loop 1, loop 2 and loop 3, and then I1 it is 5 amperes because the direction of loop current I1 and 5 amperes are one and the same. So I1 is equal to 5 amperes. Then I3 minus I2. Why I3 minus I2? Because 8 amperes is shared between loop 3 and loop 2, and that too 8 amperes direction and the direction of the I3 what we have selected are one and the same, whereas the direction of loop current I2 is acting opposite to 8 amperes. That's why it is I3 minus I2 is equal to 8 amperes. So after framing these two equations, I have to select the parameters which are connected to loop 2 and loop 3 together. So I'll start off with 5. So you have 5 I2 minus I1. Is this clear? This is the one drop. Then I'm shifting to this 2. So 2 I3 minus I1, 2 I3 minus I1. Then on the side you have 0.8 V2. So 0.8 V2 on the path, whatever the voltage, dependent voltage source is given, I'm taking that as it is over here. Then coming back to this point, this becomes 2.5 I2 is equal to 0. Okay. Now there is a catch in this problem. What is that catch? After reframing this solution as this equation, as equation 3, the catch what you have observed is the V2. V2 you can see the positive is over the top and negative is on the bottom across 5 ohms. Means what? The current is flowing from top to bottom, and V2 will be equivalent to the resistance multiplied with the difference of the currents. So resistance is 5 and the difference of current is I1 minus I2. Why I1 minus I1? You can see V2 positive plate is on the top and I1 it is entering from top to bottom, whereas I2 is entering from bottom to top. That's why it is I1 minus I2. That is the branch current value that is multiplied with 5 ohms. It becomes the voltage across 5 ohms. Now this fourth equation I'm substituting in equation 3, where I have minus 7I1 plus 7.I2 plus 0.8. You can see V2 is substituted by 5I1 minus 5I2 plus 2I3 equal to 0. Now you have I1 equal to 5 amperes. 7 multiplied with 5 becomes 35. So minus 35 plus 7.5 I2 plus 0.8 times 5 I1. So 0.85 times I1 becomes 4 I1 minus 4I2. This particular variable becomes 4I1 minus 4I2. So 4 into I1. I1 is 5. So 4 into 5 becomes 20. And here you have minus 35. Minus 35 plus 20 becomes minus 50. This you need to keep in your mind. Then you have 7.5 I2 minus 4 I2. This 5 multiplied with 0.8 becomes 4. So 7.5 I2 minus 4 becomes 3.5 I2. Is this clear? And actually you have plus 2 I3 equal to 0. So just I'm substituting the values which I have dictated. So I'll be getting the value here as 3.5 I2 because 7.5 minus 4 becomes 3.5 I2 plus 2 I3 and minus 35 plus 20 becomes 15 on the other side. So just solve equation 2 and equation 5. From 2 I have obtained minus I2 plus I3 equal to 8. And here you are getting the 3.5 I2 plus 2 I3 is equal to 50. So I2 I3 with the two constants, I'm going to get the value of I2 which is equal to minus 0.1818 amperes and I3 is equal to 7.818 amperes. Once I'm done with I2 and I3, what is my requirement? I need to obtain the value of V2. So V2 is across 5 ohms. So V2 is equal to 5 times I1 minus I2. I1 is 5. Substituting the value of I1 is 5 minus this I2 we got the value which is nothing but minus 0.1818. So I'm substituting this value. So I'm getting the answer as 25.9 volts. Please cross check this answer with my previous class that we have dealt on 12th of July 2022. So please check that video. In that we have obtained the same result using Supernode analysis. Okay. Now we need to find out the value of Vx using mesh analysis for the circuit figure in 4. So for this circuit which is shown in figure 4, we need to calculate the value of Vx. Vx it is the voltage measured across 3 ohms. So since it's a mesh analysis, directly we'll go with the supermesh analysis. So I've selected I1, I2, I3 directions like this, I1, I2, I3. then it is clearly observed that I3 minus I1, it is equal to Vx by 9. So Vx by 9, it's a current source. What type of current source? Voltage dependent current source. But since it's a current source shared between loop 1 and 3, that's why I3 minus I1 is equal to Vx by 9. This is the first catch. What is the next catch? You have Vx which is measured across 3 ohms and positives are on this side, negatives on this side. So Vx will be equal to 3 multiplied with the branch current which is flowing in 3 ohms. So that is nothing but I3 minus I2. So this is an important two catches which you have to obtain or which you have to determine by looking at the network. By looking at the network straight to the circuit, you are going to get the value of I3 minus I1 is equal to Vx by 9 and Vx is equal to 3 times I3 minus I2. Now just substitute 2 in 1. I'm going to get I3 minus I1 which is equal to 3 times I3 minus I2 by 9. So 3 multiplied 3 becomes 3 3s are 9. So I3 minus I2 by 3. Now just cross multiply. So this becomes 3 I3 minus 3 I1 is equal to I3 minus I2. Now just reframing the equation. And since we know the value of I1 which is nothing but 15, I1 it is clearly mentioned as 15. So I'm substituting the value for I1 in this equation. I'm going to get I2 plus 2I3 is equal to 45. So this we have framed as equation 3. I hope this step is clear to all. If at all you have any queries, please comment on the chat box. Now applying KVL to loop 2. Why? We are done with super mesh, that is I3 minus I1. We are done with this. That's why directly we are going to loop 2. So in the loop 2, I'm starting with 1. So 1 I2 minus I1. This is a drop over here. Then shift to 2. This is 2I2, another drop. And this 3 shared by I2 and I3. So 3 times I2 minus I3 equal to 0. Just resolve the equation. We are going to get the value as 6I2 minus 3I3 is equal to, you have I1 value as 15. So this is on the negative side. So minus 15 tends to positive 15 on the other side. So just solve equation 3 and 4 and we are going to get the value of I2 which is equal to 11 and I3 which is equal to 70. What is the requirement? Vx is the requirement. So Vx is equal to 3 times I3 minus I2. So 3 multiplied with 17 minus 11 which is nothing but 6 multiplied with 3 which becomes 18. So 18 volts is the answer. So this we have done with mesh analysis. You please cross check the result with node analysis. It's not a supernode problem, it's a simple node analysis problem. You select the nodes, you can select this node as one node, this as another node, and this as third node. With the nodes, you can get the value of V1, V2, V3. Then what is the requirement? Requirement is, if at all you select this one as V2 and this as V3, so Vx will be equal to V2 minus V3, that you are supposed to get the value as 18. So please solve by yourself and comment in the chat box whether you are obtaining the same result using node analysis or not. I am waiting for your result for this particular problem. Please comment on the chat box whether you are able to find the solution or not. So in today's class we are done with Supermesh analysis, especially the problems involving dependence and independent sources together. I hope you like this video and share among your friends. And as a requirement, please subscribe to my channel and please press the bell icon for the future notifications. Thank you.